This is 3-2, angles formed by parallel lines and transversals. Try the warm-up, pause the video, and hit play when you're ready to hear the answers. Angle 1 and angle 3 are corresponding angles. If you lift the first group of 4 up, add it to the second group of 4 angles, the 1 and 3 would line up. So those are corresponding angles. Angle 3 and 6 are in the interior and they're on opposite sides of the transversal. That's alternate interior angles. Angle 4 and 5 are in the exterior and they're opposite sides of the transversal, so that's alternate exterior angles. And angle 6 and 7 are on the interior, but they're actually on the same side, so those would be same side interior. Okay, let's take a look at the corresponding angles postulate. The corresponding angles postulate says, if two parallel lines, which we know they're parallel by the arrows here, if two parallel lines are cut by a transversal, then the pairs of corresponding angles are congruent. So since 1 is corresponding with 3, 1 is congruent to 3, shown by the statement to the right. Angle 2 is congruent to angle 4, because those are corresponding, etc. Example 1, using the corresponding angles postulate. Find each angle measure using the corresponding angles postulate. So angle ECF is what we're going to be needing to find. This angle right here. Well, what is that corresponding to? Remember, if I pick up these 4 angles and I drop them onto the next 4, what would be in line and sitting in the same position as FCE, or ECF I should say. And that would be the 70-degree angle. So ECF is also 70 degrees. And DCE. To find DCE, since we know it's corresponding to ABC, then we could set those two congruent to each other. So we have two parallel lines cut by a transversal, and now we're looking into figuring out angle ADCE. Well, since these are corresponding, we set them equal. 4x plus 22 is equal to 5x. Subtract 4x from both sides. 22 equals 1x, or just x. So to find the measure of angle DCE, which is this angle here, we would do 5x, which is equivalent to 5 times 22, since x is 22, 110 degrees. Okay, find each angle measure using the corresponding angles postulate. Well, we know that this angle is 80 and angle x corresponds to that, so x is going to be equal to 80 degrees. So find the measure of angle, let me go back. So the measure of angle ABC then is equal to 80 degrees. Okay, angle DEF. Well, DEF is right here, and that's corresponding with angle D. I don't have enough letters to name that. So what I would do then is set these equal to each other since they are equal. Subtract x from both sides, add 45 to both sides. I just did that at the same time to save a step. And so it ends up with 1x is equal to 75. And I can plug that back in to find measure of angle DEF. So since the measure of angle DEF is equal to x plus 30 degrees, then we can go ahead and plug in x, which was 75. 75 plus 30 is 105 degrees. Okay, this next one is a two-step problem. So it's asking us to find the measure of angle QRS. Well, I see that we have a couple corresponding angles. Since these are corresponding, then 118 degrees is equivalent to x degrees. Okay, and so if that's 118 degrees, and these are on a straight line, what's the measure of this angle QRS? Well, since it's a linear pair, we would do 180 minus 118, which is 62. Let's make sure our answer makes sense. It is an acute angle, so 62 degrees makes good sense for that. So the measure of angle QRS is equal to 62 degrees. Okay, now we have three theorems. The alternate interior angles theorem. If two parallel lines, as shown by the arrows, are cut by a transversal, then the alternate interior angles are congruent. So in this case, like angle 1 is congruent to angle 3, and angle 2 is congruent to angle 4. Alternate exterior angles. If two parallel lines are cut by a transversal, then two pairs of alternate exterior angles are congruent. I think you're seeing the pattern here. So 5 is congruent with 7, 6 congruent with 8. Okay, for same side interior angles, if two parallel lines are cut by a transversal, then the two pairs of same side interior angles are supplementary. So for instance, angles 1 and angle 4 are supplementary. They add up to 180 degrees. Okay, first we need to find the measure of angle EDG. I've marked this with the blue highlighter. I do know that that angle is corresponding with 2x minus 135, so I can set those equal to each other since we know they're congruent. We have parallel lines shown by the arrows cut by that transversal. So we have 2x minus 135 is equal to x minus 30. Subtract x, we end up with x minus 135 is equal to negative 30. Add 135, we end up with 105. So the measure of angle EDG, is equal to x minus 30 degrees. Since we found that x was 105 degrees, we do 105 minus 30 degrees. So measure of angle EDG is equal to 75 degrees. Since measure of angle EDG is 75 degrees, if we look at our figure, and these are parallel lines cut by a transversal, then every acute angle is going to be 75 degrees. That's on here. Think about this. If this angle is 75, then this angle is also 75 because they're vertical angles. If angle, can't call it angle D, but if this angle right here is 75 degrees, then the x is a linear pair with that, and so it's 180 minus 75, so that's 105 degrees. So the measure of angle BDG is 105 degrees. Okay, the measure of angle EDF. EDF is right here. That's x right now. Every obtuse angle, because these are parallel lines cut by a transversal, every obtuse angle is going to be 125 degrees. So I already know this is 125 degrees. The other reason why it's 125 degrees is these are alternate exterior angles, and alternate exterior angles are congruent when two parallel lines are cut by a transversal. To find the measure of angle TUS. Well, TUS is 23x, and it's the same side interior with angle RSU. These two angles are same side interior. Same side interior, when you have parallel lines cut by a transversal, add to 180. So I do 13x plus 23x equals 180 degrees. Add these together and I get 36x equals 180. Divide both sides by 36, and x equals 5. So I plug that back in, 23 times 5, because of the 23x, and 23 times 5 is 115 degrees. That makes sense because it's obtuse. For this one, I've highlighted the angles and the angle measure so you can actually tell what it's pointing to here. So we're looking for the measure of angle ABD. Well, these are both alternate interior angles, and when you have parallel lines cut by a transversal, the alternate interior angles are congruent. So I set up 2x plus 10 equal to 3x minus 15, and then I subtract 2x from both sides. 10 equals 1x minus 15, add 15 to both sides, and I get that 1x equals 25. Okay, and I plug that back in to measure angle ABD. So into 2x plus 10, well, 2x plus 10, if we plug in the 25, becomes 2 times 25 plus 10, which is 50 plus 10, which is 60 degrees. This makes sense because it's a cube. Measure of angle ABD is equal to 60 degrees. Okay, in this word problem, we have parallel lines cut by a transversal. We've got this 55 degrees and the 60 degrees. We have the 5x plus 4y and the 5x plus 5y. Okay, so all of these pink spots will be alternate interior angles. So I know that my first equation can be 55 equals 5x plus 4y. And for the second one, the 60 degrees is corresponding to the 5x plus 5y. And so that's my next equation. And we can use, since we have two variables here, we're going to need substitution or elimination to solve this system of equations. I would use elimination. The 5x's almost cancel. I can make everything on the bottom negative. So now the x's cancel, and I end up with negative 5 equals 4y minus 5y is negative y. Divide both sides by negative 1, and y equals 5. So I can plug that into one of these equations. 55 equals 5x plus 4y. Well, instead of y, I'm going to put the 5 that we just got. And then we get 55 equals 5x plus 20. Subtract 20 from both sides, and I get 35 equals 5x. Divide both sides by 5, and x equals 7. So y equals 5, and x equals 7.